so third part of chain rule. We started with chain rule, then we mixed chain rule with product rule and quotient rule. So now we're going to look at the extended chain rule, which is also called the nested chain rule, which is also called chain rules within chain rules within chain rules, or however you want to say it. Okay? So before we get to the candy, I want you to look at A. I talked about this notation a little bit yesterday just because I didn't realize that there was one on the problem. We're going to skip over this for right now. We'll come back to that. But cosine to the fourth of 5x, that is the same thing as cosine of 5x all to the fourth power, right? And I think it's a good idea to write it that way so you don't miss anything in the chain rules when you're doing these. But in the end, we've got to put it back into this, all right? So you've got some M&Ms in front of you. They have a candy shell just like your suckers did, right? But obviously it's a different candy. So go ahead and grab one. Okay. Now, since it's an M&M, there's chocolate in there, right? Can you get to the chocolate without breaking through that candy shell? No, you cannot, okay? So try and just break one. See if you can break it. We'll grab another one. See if you can break it. You may not be able to. You might have to kind of bite it. I didn't try to actually break these because I know you can break some. Here, let me try. Okay. So you have to break through yeah, you can't really break these. So, okay. So you can bite it. So you have to get through the candy shell to get to the chocolate, right? And then there's something inside the chocolate. Can you get to what's inside the chocolate without going through the chocolate? No. So you have to go from the inside out. Even if you pop the whole thing in your mouth and you eat it, when you bite down on it, you're going from the the outside in. I just said it wrong. You can't go from the inside out. That's my point. Okay? So what is that middle part? Can you tell? It's a pretzel. I didn't want to get peanut M&Ms, but I needed to have 3 layers because those suckers I gave you only had 2 layers, right? This has 3 layers. Okay? You can eat the rest of them. You could, get through the candy shell, then try to get to the chocolate. I don't know if you eat peanut M&Ms like that, but I do sometimes. You get the candy shell, then you get the chocolate, then you get the peanut, and just kind of. But however you want to eat them. But I want you to remember these when you have more things here. So let's look at how we're going to work this while you're eating your 3-layered candies here. Let's look at chain rule. I know I have to do some sort of chain rule because I have a function. This function is within the x to the fourth function, right? But then look in my cosine function. There's a function inside of that. So I have a function in a function in a function, right? So let's just work this, see how it works, and then we'll talk about what the actual rule is. So let's go through the chain rule like we know how to go through the chain rule. We're going to work from the outside in. We're going to do that candy shell. So we put 4 out in front and then parentheses. And this is something some of y'all were struggling with yesterday. I'm just doing this part, and then I rewrite what's inside. We're not touching that. This is all just the candy shell here. So then I still have the cosine of 5x, and then that becomes to the third power. Okay? Took care of the candy shell, right? Then I go to the inside part here, right? That inside is the cosine of 5x. That's the chocolate of what you have. So we're going to take the derivative of that. What is the derivative of cosine? Negative sign. So I have negative sign, and I do not mess with the argument. It's cosine of 5x. That stays the same. So I've taken the candy shell. This is the chocolate part. Okay. I'm glad you're here, though. I'll see you next period. Okay, you might not have been late if you went to the right class. Okay, so I have the candy shell. This is the chocolate, just the inside. And then I have to take care of that pretzel part right there. What's the derivative of 5x? 5. Only the first one, because we're working from the outside. So this is the outside. That's a good question. I only have the cube here. Then I only look at, so the second part here, I only look at this for the second part. And then I only look at this for the third part. Okay, that makes sense? So outside in, no matter how many layers you have. We could have 20 layers, which would look insane, but you would still just go from the outside in as you go. Okay, does that make sense to you? All right, so let me show you what the rule really looks like, and this is one reason why we don't really want to just mess with the rules. We want the concept better. So I have f, instead of just f of g of x, I have f of g of h of x. So it would look like this. We work from the outside in. This would be f prime of g of h of x. That's your candy shell. The chocolate is the g part. So then I take the derivative of that g part, and that's g prime of h of x. And then the pretzel is the h of x times h prime of x. So the rule looks disgusting. But I don't want you remembering it looking like that anyway. I just want you to think of it going outside in. Think of your candies. Okay, we good with that? What questions you got? Okay. Ready for B? I'm sorry. Oh, well, okay, yeah. Let's clean this up. So this is my safe stop. I'm glad you said that. This is my safe stop, but let's clean this up a little bit. So I have the 4 times 5. I'm going to multiply those two together. So my dy dx is equal to 4 times 5, so that's 20. I'm going to change this back to where I put the exponent here. So this is 20 times the cosine cubed of 5x. And then since this is negative sine of 5x, I'm going to put my negative out front and then make this the sine of 5x. Notice that whatever is inside of my trig right here is still inside of my trig when I'm done. If you changed those things, something went wrong. And some of you were changing those things yesterday, so let's make sure we know not to do that. Are we good? Okay. So do I need to rewrite anything in B before I start? What do you think? Should I rewrite this first? Yes. So this is going to be equal to secant of 4x cubed plus 5, all of that squared. All right, so I'm going to start from the outside, the candy shell part. This is going to be 2 times secant of 4x cubed plus 5, and then that would be to the first power, but so I'm just not going to write one. That's the outside part, right? That's your candy. Then we do the chocolate. The chocolate's the inside right here. What is the derivative of secant? Remember, psst. Yeah. Psst, right? So tangent is secant squared, secant is secant tangent. Tangent secant's the same thing, but you'll see it as secant tangent when you see the rule. So here's the deal. When we do this, remember, this argument stays the same. The derivative of secant is secant of whatever that is, 4x cubed plus 5 times tangent of whatever that is, 4x cubed plus 5. Okay? Pink is the candy shell. Green is the chocolate. I took the derivative of secant to 4x, secant of 4x cubed plus 5. We good? How many more layers we got? One more. So then that last layer is this right here. That's your pretzel. Got to take the derivative of that, which is going to be 12x squared. And then that's it. So those are the pieces that I have. I did them in different colors so you can see what each one was. So you don't lose track of whether or not you already did it. And notice every trig thing I have in there has the same argument. It all matches the original. Don't change what's inside there. So now when I go to clean it up, and I can say that I have f prime of x, these parentheses right here, they don't really do anything, right? So I have I can do the 2 times the 12x squared. That'll give me 24x squared. You could also, as you go through, not a bad idea, I do this sometimes when I have like a ton of stuff, like I'm going to mark them out because I already used them. I don't want to accidentally use them again or do something weird. Then I have secant times secant, and they're the same, right? So that's going to be secant what? Squared. So that I can have secant squared of 4x cubed plus 5 times tangent of 4x cubed plus 5. That's my derivative. Okay. What questions you got? Okay. I'm going to have you go through the first steps of C on your own, but should we rewrite this as something before we start? Yes. We're going to rewrite that as the sine of 7x to the 1/2 power. Okay, so just get the first row of your work done, and we'll make sure we're all together and then clean it up from there. Okay, do we all have the first set of steps? So I'm going to talk you through it here. We're going to do 1/2, going to come out front, so I get 1/2 times the sine of 7x to the negative 1/2 power. Okay, that's the candy shell. I didn't touch the sine or the 7x. Then I go into what's inside of those parentheses to the 1/2 power. The derivative of sine is what? Cosine. So this becomes cosine of 7x. I do not touch that 7x. Then I go inside of that, take the derivative of 7x, which is just 7. Do we agree with that? So everything's being multiplied together. I have a negative exponent, so that means I know my answer is going to be a fraction. In the numerator, I'm going to have a 7 and the cosine of 7x. These two things go in the numerator. This 2 will go in the denominator, and you could leave this to the 1/2 power, or we could put it as the square root of the sine of 7x. But notice every trig argument matches the trig argument that we started with. What questions do you have? So same process, you just got one more step because you got one more layer in there. All right. Any questions? All right, so then let's do D. So I have, again, a function and a function. 2x is inside of tangent, which is inside of sine. So I've got 3 layers there. To start from the outside, I just do sine. So the derivative of sine is cosine. So I'm going to have the cosine of the tangent of 2x. Everybody with me? Then I'm going to take the derivative of tangent of 2x. What's the derivative of tangent? Secant squared. So I have secant squared of 2x. Then I take the derivative of 2x and I get 2. Okay. So really the only thing to do here to clean this up is to bring that 2 out in front. 2 times the cosine of the tangent of 2x times secant squared, times secant squared of 2x. There's your answer. What questions do you have? If you needed to take the second derivative, then we would have to use chain rule and product rule, right? Like we're not going to do that right now, but that's what we would have to do, right? Okay. Questions? Oh, look, we have a second derivative here. Okay, so chain rule, within chain rule, within chain rule, possibly, but really here, so let's start off with finding this. So I've got f prime of x. So to find the derivative, I'm going to do the outside. So 3 times 4 is 12 times x squared minus 5 to the second power. Right? That's the candy. Then I take the derivative of the inside, which is going to be 2x. So that was just plain old chain rule, right? We just had 2 layers there. So I'm going to rewrite this so that finding the second derivative will make it a little bit better. This is going to be 24x times x squared minus 5 squared. Okay. Everybody with me so far? Okay, we good? All right, so then I have to do second derivative. Is this just plain old chain rule? What do I have to do here? Product rule and chain rule, right? So when I start, I want to think about what's being multiplied. This 24x is being multiplied by what I have in parentheses there. So to do the chain rule, my rule is I take the derivative, to do the product rule, my rule is to take the derivative of the first, so the derivative of that is 24, times the second, which is x squared minus 5 squared, right? The derivative of the first times the second, plus the first times the derivative of the second. So when I take the derivative of this is going to give me 2 times x squared minus 5 times what? 2x. Okay, because I did, this is the outside, this is the inside. So this is a safe stop. We have 2 options here. We can clean it up a little bit and then see what we can factor out, or we could start by factoring out now. What would you prefer? You want to factor out now, see what they have in common, and then leave what's left? Okay, I can factor out a 24 and an x squared minus 5, because there's my 2 big terms, right? I can factor out a 24, so that would make that one go away, and I can factor out they both have an x squared minus 5 in common. Okay. So when I do that, this is what has happened. I have divided that out, and I've taken one of those. I've taken the 24, and I've taken all of that. Okay, so if I kind of mark it out, that helps me see what I have left. So what I have left, my first term is just going to be x squared minus 5 plus, then I have 2 times x times 2x, which is 4x squared. That's what I have left. So notice that this whole, everything that was left, I got to put the whole thing of that in parentheses, right? Can I clean that up just a little bit more? Yes. So my f double prime of x is equal to 24 times x squared minus 5 times what? 5x squared minus 5. So that could possibly be a multiple choice answer. We had a safe stop right here, but even with the safe stop, you might want to clean it up even if you don't factor things out. Okay, so by cleaning it up, I mean we could have from here said that this is 24 times x squared minus 5 squared plus, and then I'd have 4x times 24x, which would give me 96x squared times x squared minus 5. Like, depending on what we want to do with it, we might want to at least combine some stuff. And then I could have, from this point, factored it out. I have the same answer. So whatever makes the most sense to you, logically, will be fine. Okay, what questions you got? We good? All right. So let's do f. So I want to find f double prime of x and then evaluate it at that point. All right, so to get f double prime, I have to start with f prime. What is the derivative of sine? Cosine. So this would give me cosine of what? 3x, because I do not change that. Then I have to multiply that by what? 3. So this is really 3 times the cosine of 3x. That would be better for me to have it in that form in order to do the second derivative. So second derivative of x is, okay, what's the derivative of cosine? Negative sine. So I get negative 3 sine of what? 3x. And then I take the derivative of the inside, which is 3. So I end up with negative 9 times the sine of 3x. Okay, so that is the second derivative. That was one thing we had to find. Any questions on where any of that came from? Okay, so now we're supposed to evaluate it. So I want f double prime of pi over 18. So that's equal to negative 9 times the sine of 3 times pi over 18. Well, what's 3 times pi over 18? Pi 6. So this is really negative 9 times the sine of pi 6. Right? What is the sine of pi 6? Pi 6, 1/2. So this is negative 9 times 1/2, which gives me negative 9 halves. By the way, check this out. Sine of 3x, sine of 3x, right? If I want to evaluate it at this point, well, if this is a point on this function, when x is pi 18ths, f of x has to be 1/2. So I already really know that this part is 1/2, and I just have to multiply it by negative 9. That's another way to do that. Do you recognize it? Well, you had to find it, and then you could just substitute it in since they match. Yeah, so you could have skipped most of what was in green, but not the other stuff. What questions you got? All right. See what this derivative looks like. We'll do one more together. And then, oh, 2 more together, I guess. So this is one of those, what it might look like on the AP exam. So we want to find the derivative of this. Should I rewrite it first? Yes, I should rewrite this as the sine of 3x plus 7 squared. Do I want the first derivative or the second derivative? The first, okay? So dy dx is 2 times sine of 3x plus 7 to the first power, right? So I don't need anything. That's the candy shell. Then I work on the chocolate. The derivative of sine is cosine, so that's the cosine of 3x plus 7. Then I work on the pretzel. That's the inside part, and that is 3. So this gives me 6 times the sine of 3x plus 7 times the cosine of 3x plus 7. And there wasn't anything to factor out or change. And luckily it looks exactly like D. But had we had cosine first, would we have been fine to pick D? It would have been fine, right? All right. You take the derivative in number 2. double check your first step with me. And if you're not sure where I got something, let me know. Yes, I can. So, am I going to use the chain rule here? Yes. What else am I going to use? The product rule. I have a product here. So I took the derivative of the first times the second plus the first times the derivative of the second, and then the derivative of the second is where I had to use the chain rule. Okay. Then once you get it there, see if you can simplify it and make it match one of these multiple choice answers. So I cleaned mine up a little bit first. You wouldn't have to do that before you factor. So if you didn't do the step I just wrote, it's not the end of the world. I'm not finished. Obviously, my answer doesn't match any of these. That's what I would get after I factored something out. But then I'm still not matching any of these, right? So this is x squared plus 2 squared. And then in here I have x squared plus 2 plus 6x squared minus 6. So that gives me x squared plus 2 squared times 7x squared minus, oh wait, oh this should be 6x, I'm sorry, when I distribute, I didn't distribute correctly, that should be 6x, 7x squared minus 6x plus 2, and that matches D. What questions do you have? So it's not all about just getting the derivative correctly. That's very important, obviously. But then you have to take what you have, and you may have to manipulate it to match somebody else's answer. Any questions at all? Are you confused? Ask me a question. Where did I lose you? Oh, okay. The putting it together up here? Step 3? Okay. So when you do that, right, and this is, so you look at, I've got this term and this term, and I got to see what they have in common. So the only thing they have in common is that quantity of x squared plus 2, right? So I can take out 2 of them. So this is what I took out. So when I did that, I don't have 3 of them anymore. I only have 1, and then I'm marking that out. So if you mark it out as you do it, it can help you. So then what I have left is 1 of this times, I have 1 of these plus, and then this is what's left here. Okay, and then I combined it. Yeah, so there's a lot of numbers. There's a lot of everything, right? So it does help to kind of mark it out as you go along so that you're not trying to use something twice or get lost in it. Anything else? All right, so your assignments that you have 2 assignments that are pink. There's a couple of questions on there I told you to skip. Unskip them because now you can do them.